Hi everyone, welcome back to Array series. Hope you are doing good. This is Mahesh. In this video, we are solving Leetcode problem number 75, which is sort colors. So let us look into the statement of the problem. So given an array nums with n objects colored red, white or blue, sort them in place so that the objects of the same color are adjacent, with the colors in the order red, white and blue. So basically 0, 1 and 2. Okay. We will use the integers 0, 1 and 2 to represent the color red, white and blue. That's what they are saying here. Then you must solve this problem without using the library's sort function. So basically you should not use the inbuilt sort function here. Then they have given some examples and also they have given the constraints. N will be the length of the nums array and it will be between 1 and 300. And nums of I is either 0, 1 or 2. So any value in the nums array will not be other than 0, 1 and 2. With this, let us switch to the editor and let us try to understand the problem in detail. So basically they will give us the nums array. Okay, so the values in the nums array will be 0, 1 or 2. Only these three numbers. So that is one of the constraints. And if you see what they have given, so 0 represents red. So here I have already mentioned. So 1 represents white and 2 represents blue color. So they want us to sort these colors in the given order. So it means it should be 0, 0, 1, 1, 2, 2 for this particular array. So if we sort it, we will get this particular array. So that is what they are expecting us to do here. So basically it's a sorting problem only. But only thing is the given elements are 0, 1 and 2. No other elements apart from 0, 1 and 2. With this, we understood the problem statement clearly, and also we have already seen the constraint. So maybe what you can do, you can pause the video and you can think for any possible solution and then you can come back. So now we will try to understand its intuition a bit later, but here as in the problem statement, we need to solve this in O of n time complexity and O of 1 space complexity. That is what the interviewer will be expecting us in this problem. Okay, with that, now let us try to understand the brute force solution. So what is the brute force solution? Don't worry about any constraints. Simply think about what is the naive, extreme naive solution, naive possible solution. So basically we will have to sort this particular array, right? So we will simply use any inbuilt sort method, and if we sort the given array, then we will get the sorted values. Correct, right? But that is going to be extreme naive solution and its time complexity will be of order n log n. Why? Because even if we use the most optimal sorting technique like merge sort, then in that case also it will be n log n time complexity. Okay, and maybe space complexity would be order of 1. Okay, so if you see, this is little bit costly. So we need to optimize this particular solution. So instead of using the inbuilt sort method, we will try to come up with something else. So what is the better solution then in that case? So what is the better solution? So now it is clear, right? The input array will contain only 0, 1 and 2. If that is the case, then what we can do, we can simply count the number of zeros, number of 1's and number of 2's. Correct, right? So that we can do. So if that is the case, let us consider this particular second example so that our dry run makes much more sense. So now what I will do, I will simply count zeros, how many zeros are there in this particular array, how many 1's are there, how many 2's are there in this array. So with that, so what I will do, I will say zeros, then 1's, then 2's. Okay, so we get 2 here. So I will increment the count of 2's to 1. So basically, we will start with all the values 0. Then I will increment it to 1. Again, next number will be 0. So I will increment this to 1. Next number will be 2. So I will increment this to 2. Next number will be 1. So I will increment 1's to 1. Next number will be again 1. So I will increment it to 2. Next number is 0. So I will increment it to 2. Next number is 2. So I will increment it to 3. Next number is 1. So I will increment it to 3. Next number is again 1. So I will increment it to 4. Next number is 2. So I will increment it to 4. Again next number is 2. So I will increment it to 5. Next number is 0. So I will increment this to 3. So now if you see, there are 3 zeros, 4 1's and 5 2's. Now what I will do, I will use these counts and I will rewrite the numbers in the original array. So basically what I will do, I will simply, so since there are 3 zeros, the initial numbers I will make them as 0. Next after that we have 4 1's, so I will make these 4 1's. Next after that the remaining 5 numbers will be 2's, so I will overwrite these numbers as 2's. So if you see, there are 5 2's, there are 4 1's, there are 3 zeros. Okay, so if you see now, we are doing it in 2 passes. Basically, one pass we will use to count the 1's, 0's, 1's and 2's. Then in the next pass, we will overwrite in the original array. Correct, right? So let us look into the pseudo code now. So now what I will do, I will take the count variable and I will consider it as an array of 3 values. So 3 values represent, 0 index represent the number of 0 count, index 1 represent number of 1 counts, index 2 represents number of 2 counts. So basically it is an int array or simply array of size 3. Okay, so I will take this particular array. Then what I will do, I will iterate in the array from I equal to 0 to n. Then what I will do, I will simply say count of nums of I. Then I will simply increment it. So what I am trying to do, so this is my count array. So basically this holds, first index holds number of zeros, second index holds number of 1's and third index holds number of 2's. Correct, right? So basically count of nums of I means whatever is the number, so it will be either 0, it will be either 1 or it will be either 2, right? So whenever we encounter 0, it will increment this particular value. Correct, right? Now whenever it encounters 1, it will increment the 1's count. Whenever it encounters 2, it increments 2. So that's what I do here. So initially these values will be 2. Then whenever it comes across any number, it will simply increment its count something like this. So based on the value which appears. So with this, I close this. Now this, what it does, it will create this number of value, number of 0's, 1's and 2's. After that, what I will do, I will use one more loop for I equal to 0, I less than 3, I plus plus. Basically, I will iterate over each of these values and I will try to override the original array. So before that, I will take a index equal to 0. This value will give me the reference of this particular array here. So this is 0. Then once I update this value, I will increment that. Then after incrementing, it becomes 1. Then I'll update this value. Then again, I'll increment something like that I'll do. Then what I will do, I will iterate from for I equal, j equal to 0. This is one more pointer. J less than count of I. So I is basically the count of 0, 1 and 2. Then j plus plus. Then what I will do, I will say my nums of index will be count of I. Okay, so after this I will simply increment my index. Okay, this will replace the values in my original array. Okay, now I will close this and it is done. Now if you see in the first iteration, it is of order n, it will simply count as 0's, 1's and 2's count. Then in the second iteration, so even though there are 2 for loops, it is only of order n. How? If you see here, this for loop will run only for 3 times. Once it is for 0's, second time it is for 1's and third time it is for 2's. Okay, then if you see, this particular loop only runs for as many number of values that we get here. Okay, so here it should not be count of I, it should be only I, my bad. Okay, so with that, so this also will be solved in O of n time complexity. That's why our time complexity, maybe here we can write, it is of order 2n. Okay, so basically it uses 2 passes. Okay, next our space complexity, since we are not using any extra array here, it is of order 1. Okay, so with that, let us try to execute this and see. So let us take a variable int n equal to nums dot length. Then I will take another array of size 3 and I will call it as count, and I will say new int of size 3 and I will initialize it with 0's, or we don't need to initialize also, by default it takes 0's. So I will remove this part. Then what I will do, I will use a for loop. Maybe you can use for each or for each loop also, or normal for loop also. So I'll use a for each loop int num colon nums. Then what I will say count of num plus plus. Okay, so this will increment the counts of 0's, 1's and 2's. Then what I will do, I will take another variable which is int index. So this is basically to replace the values in the original array. So it starts from 0. Then I will use another loop int I equal to 0, I less than n and I plus plus. This is basically iterates over our count array, and it will take the 0th count, the 1's count and the 2's count, and it will try to update those values in the original array. Then I will use another for loop for int j equal to 0, j less than, here it is important, count of I basically, then j plus plus. Okay, now our nums of index, then I will do a plus plus to increment after that. It will simply take the values of I. With this, it will update the original nums array with the sorted values, and I will run it. It got accepted. I will submit it. If you see, our solution got submitted successfully. So if you see, we use 2 passes to sort these numbers. Okay, now is there any way where we can do this in only single pass? Let's see. For that, what we will do, we will use Dutch national flag algorithm. This is a very famous algorithm. So we will use that algorithm to solve this particular problem in only one iteration. So how to do that? Maybe what I will do, I will take this. Since our array only contains 0's, 1's and 2's here. Then in order to sort, we need to place 0's first. Then we need to place 1's in the middle. Then we need to place 2's at the end. Correct, right? If we do that, then somehow we have sorted the array. So if that is the case, now to do that, what we need to know? First, we need to know the position of 0, where we need to keep the 0. So we will call it as low pointer. Okay, we will basically consider 3 pointers. Why, I will tell you. Now we also need to know the position of 2. Okay, so what I am trying to say, first consider the array. If you find 0, then move it towards left. If you find 2, you move it towards right. Then if you find 1, you try to keep it at the middle. Okay, so for that we need to know where we need to keep the 0. We need to know where we need to keep 2. Correct, right? So for this, I will say it is a high pointer. Okay, then I want to see where 1 lies. So basically, or I want to process the numbers. For that, I will take one more pointer, which is my mid pointer. So basically, you assume this mid will point to 1's for now, but that is not really the case, but you consider that. So basically, we need 3 pointers: low, high, and mid. Okay, now if you consider any sorted array, something like this: 0, 0, then 1, 1, then assume at the end we have 2 2's. Okay, we still have some more elements to be sorted. Correct, right? Now if you see, these are in their sorted order, 1's are in their sorted order, 2's are in their sorted order. So it means if you keep a low pointer here, or basically if at all we get any next 0, then that should come and sit here, right? So I will say it is my low pointer. Okay, now if you get any 2, then you need to put it at certain position here, right? So I will call it as high pointer. Okay, now from here it is sorted, here it is sorted, here it is sorted, but here it is not sorted, right? So it means I need to process this part. So for that I need 1 pointer. So what I will do, I will take 1 pointer and I'll put it here. So I will call it as mid. So mid, we basically use it to process the elements. So now if you see, from 0 till low minus 1, this is my low minus 1. This is the 0 values basically. Okay, then if you see, from low to mid minus 1, this is our 1's. Okay, then if you see, from high plus 1, this is high plus 1, till n minus 1, it is our 2. Correct, right? So we will write that here. From 0 to low minus 1, it is 0's. Okay, from low to mid, minus 1, it is our 1's. Okay, then from high to n minus 1, it is our 2's. Then whatever is there between mid and high, that is our unsorted array. So whatever is between mid and our high pointer, this is our unsorted array. This is our unsorted array. So basically, we will use this particular logic, this unsorted values, to again sort them. So we will have to shrink this unsorted part, and we need to shrink. So now if you see, at any point, if at all we want to sort, say for example, if this is the part I am trying to sort, if I get any number, if it is 0, if I get 0 here, then I should know where I should put that 0 somewhere here. So that is this place, correct, right? So this place is being pointed by low pointer. So what I'm trying to say, low points to our the index where our 0 needs to be placed, and if you see our high pointer, it points to a place where our 2 needs to be placed. So, and if you find any 1's in between, then you can simply ignore them because they are already at their right place. So what I am trying to say, if you find 0, simply replace that at a place where low pointer is pointing. If you get a 2, then go to the right and replace at a place where our high pointer is pointing. Okay, let us take this example and let us try to dry run that. So I will copy this. Okay, I will paste it. So I'll try to make it more simple. So now assume initially, I mean, entire part is unsorted array, right? So if that is the case, then it should be between low and our high pointers, correct, right? So this is our low pointer and this is our high pointer. Okay, this is our low, this is our high. Okay, then I want to process the elements. For that I need mid. So mid means since all the elements are not sorted, so I will place my mid here. Okay, so I'll place, this is my mid. Okay, now what we understood, this pointer points to the index where our 0 should come and sit, correct, right? This is the pointer where our 2 goes and sits. So now if you see, we get 2. So 2 means our mid is pointing at 2 because this is the first element it is trying to process. So if I have gotten 2, then what I will do, I will simply swap this with my element at the high pointer. Okay, so I will do that. I will take a different color. So I will swap 0, then this becomes 2. So now this 2 is already in its correct position. So if that is the case, now my high pointer should move one position left because next it has to place the 2 at that next index. So what I will do, move this to the next value. Okay, next what I will do, again I will try to process the numbers. Now if you see, now at the mid I have 0. So if I have 0, then it needs to move towards left, correct, right? So what I will do, I will simply swap the number at low index and mid index. But since they are same, I mean, it is as good as getting swapped. Then after that, now my low should point to the next 0. So for that, what I need to do, I need to move this to the next value. If that is the case, now I have successfully processed this particular value, right? I will also need to move my mid pointer. Okay, so with this it will move to the next number. Okay, now I am trying to process the next number. So since again it is 0, our pointers will move to the next value. Okay, now if you see, again we get 2 here. So if we are getting 2, then 2 should go towards end. So what I will do, I will swap this with this number, correct, right? So I will do that. I will swap this 2 and 2, correct, right? Even though it is same, we are simply swapping. Now this place is the correct place for 2. If that is the case, this should move. So I will move this to the next value. Next, I will try to process again this particular number. So now again it is 2. Okay, so again I need to swap this with this number. So now what I will do, I will simply swap it with this number. Okay, now after that our high should point towards the left because these numbers are already sorted. Now if you see, this part is sorted, this part is sorted, correct, right? This is only the unsorted part. This is what we are trying to process using our mid, low and high pointers. So these pointers always point to the unsorted values. Now what I will do, again I have 2 here, correct, right? So I have 2 here. This should be swapped with this particular number. So I will do that. I will swap this. Sorry, this should be 1, then this should be 2. Okay, with that I will move this pointer to the next number. Okay, now if you see, we get 1 here. So now this is very important. When you get 1, it means it is at its right place. So if that is the case, we only need to move our mid pointer to the next possible index. So now what I will do, I will simply erase this and it gets replaced with 1. Now I will move my mid pointer to the next index. Okay, now if you see, again we get 1. So if that is the case, I will have to move to next, but again there is 1. So I will move to next number. Now I will see, I get 0 here. So if I get 0, so now you see what we need to do, we need to push this to the low pointer where the low pointer is pointing, correct, right? So this is the correct place for us to put 0. If you do that, then 0 will move here and this value will move here. Okay, so let's do that. I will move that 0 here, then this 1 will come and sit here. Okay, now if that is the case, our low pointer here, its work is done, so it has to move to the next index. So I will move this to the next index. Okay, now if you see, our mid is pointing to 1, so it is at its right place. 1 is at its right place, so our mid moves to the next number. Okay, now if you see, we get 2, so if I get 2, I will have to move towards right, so where high pointer is pointing. So I will do that. So this becomes 1, this becomes 2, correct, right? Now if that is the case, our high pointer moves left. Okay, now if you see, our value here is 1, not 2. It is replaced by 1. So if that is the case, our mid should move to the next index. What I will do, I will move this to the next value. Now if you see, our mid has crossed high, so it has become greater than high, correct, right? So I will stop here. Now if you look here, 0, 0, 0, then 1, 1, 1, here also 1, then 2, 2, 2, 2, 2. So it got sorted, correct, right? So this is the core logic here. So basically we are trying to move 0 towards left, 2 towards right, and we are trying to keep our 1's at the middle. So for that we need low pointer which points at where our 0 goes and sits, and we need high pointer which points where our 2 goes and sits. And the in between part, I mean, we will try to use the mid pointer to process each element. If we find 1, then we will ignore and we will proceed. Okay, with that, let us try to write the pseudocode for this one. So now n will be nums dot length, our low will be 0, I will be n minus 1, and our mid will be 0 initially. These are our initializations. Now while our mid value is less than or equal to high, what we will do, we will simply try to process the values. So basically, if you see here, we get while processing, what we get 0, we get 1, and we get 2. These are the numbers, right? If I get 0, what I will do, I will swap my low comma mid. Okay, then I will do low plus 1 or low plus plus you can say, and mid also gets incremented. This is when we get 0. So this 0 is basically nums of mid. Okay, these are the different cases. This is first case. Then second case would be like 1. If we get 1, we simply move our mid pointer. So mid plus plus we do. Correct, right? And third case would be 2. We get 2, what we do basically, we swap number at mid pointer and high pointer. Correct, right? We are not actually swapping the indexes. It is basically nums of something we do. So I'm simply writing here. Then what we do, we will decrement our high pointer. Correct, right? That's what we will do. So now, if my nums of mid, we can also use switch case statement here, but simply I'm using if else statement. So if it is equivalent to 0, then what I will do, I will swap nums of low comma nums of mid. Okay, after this I will say low plus plus and mid plus plus. Okay, then I will complete. Else if our nums of mid, if it is equivalent to 1, I will simply say mid plus plus. Okay, else it is for 2, what I will do, I will swap nums of mid comma nums of high. Okay, then I will decrement only my high pointer. Okay, this is done and we can close. So this way we will sort all the numbers in a single pass, in one pass basically. So if that is the case, our time complexity will be of order n. So I will write using normal pen. So time complexity is of order n, and if you see, we are nowhere using any extra space other than few variables. Correct, right? So if that is the case, our space complexity is of order 1. Okay, with that, let us execute this and see. Now I will remove this part. I will take low pointer, assign it with 0. Then I will take my mid pointer and assign it with 0. Then I will take my high pointer and assign it with n minus 1. Next, I will use a while loop while our mid is less than or equal to high. Then I will use a switch statement, switch nums of mid. Then I will use case 0. If it is case 0, then what we need to do, we need to swap the low and the number at lowth index and mid index, right? So that's what we will do. Int temp equal to our nums of low, then nums of low equal to nums of mid, then nums of mid equal to 10. Okay, after this I will simply increment my low pointer and also my mid pointer, and after that I will break. Okay, you can simply take out this swapping part as a separate method, and you can simply pass the array and the indexes to swap the numbers, but I am doing it in line here, so you can do that yourself. Then the case 1, so when it is case 1, I will simply say mid plus plus. Okay, then if it is case 2, I will simply copy this case 0, I will paste it here, So if I'll make it as case 2, or you can also make it as default because it doesn't contain other elements other than 0, 1 and 2, right? So after 1, anyhow default will be 2. So I will say this will be my high, then I will make this high, then mid equal to temp. So this is done, and I just need to decrement my high point. Okay, so with this it is almost done. Let me run. There is some, okay, I need to take a different variable, so I will simply say it as temp1 because it is already there. So I will run this. So I have missed a break here, so I will use that and I will run it again. So if you see our solution got accepted, I will submit. So our solution got submitted successfully with 0 millisecond runtime, which beats 100%. So this is how we effectively use Dutch national flag algorithm to solve this particular sorting algorithm. So this can be asked in different variants. So in this one, they have asked us to sort color, but in some other problem, again, they might give a different variant, but with the same problem. They might give some 3 balls with 3 different colors or something like that. So basically why it is called Dutch national flag, because we use red, white and blue colors, right, for 0, 1 and 2. So for that reason, I mean, our Dutch national flag have those colors, and if you sort, and it will look like the Dutch national flag. That's why, I mean, it is called Dutch national flag algorithm. So hope I was able to make you understand this particular algorithm. So if that is the case, please consider subscribing to my channel, and also like the video, share this video with your friends, and also if you have understood it well, please add that as a comment in the video, or if you have any other feedbacks, that also you can add as a comment. Thanks for watching the video.